a crazy game here with the atmosphere and the oceans. We're taking vast amounts of carbon from deep underground and putting this in the atmosphere. This is crazy. We should not do this. It's very dangerous. So we should accelerate the transition to sustainable energy. I mean, the bizarre thing is that obviously we're going to run out of oil in the long term. You know, there's only so much oil we can mine and burn. It's tautological. We must have a sustainable energy transport and energy infrastructure in the long term. So we know that's the end point. We know that. So why run this crazy experiment where we take trillions of tons of carbon from underground and put it in the atmosphere and oceans? This is an insane experiment. It's the dumbest experiment in human history. Why are we doing this? It's crazy.
Do you think this is a product of momentum, that we started off doing this when it was just a few engines, a few 100 million gallons of fuel over the whole world, not that big of a deal, and then slowly but surely over a century it got out of control? And now it's not just our fuel, but it's also, fossil fuels are involved in so many different electronics, so many different items that people buy. It's just this constant desire for fossil fuels, constant need for oil, without consideration of the sustainability.
The thing is, like oil, coal, gas, it's the easy money.
Right.
It's easy money. So,
have you heard about clean coal? The president's been tweeting about it. It's got to be real. Clean coal, all caps. Did you see? He used all caps. Clean coal.
Well, you know, it's very difficult to put that CO2 back in the ground. It doesn't like being in solid form.
Have you thought about something like that? Like some sort of a filter? Giant building-sized filter sucks carbon out of the atmosphere? Is that possible?
No, it doesn't. Not possible.
No?
Nope.
No.
Nope, definitely
So
not.
we're fucked.
No, we're not fucked. I mean, this is quite a complex question.
Right.
You know, we're really just, the more carbon we take out of the ground and add to the atmosphere, and a lot of it gets permeated into the oceans, the more dangerous it is. Like, I don't think right now, I think we're okay right now. We can probably even add some more, but the momentum towards sustainable energy is too slow. Like, there's a vast base of industry, vast transportation system. Like there's 2.5 billion cars and trucks in the world. So and the new car and truck production, if it was 100% electric, that's only about 100 million per year. So it would take, if you could snap your fingers and instantly turn all cars and trucks electric, it would still take 25 years to change the transport base to electric. Makes sense, because how long does a car truck last before it goes into the junkyard and gets crushed? About 20 to 25 years.
Is there a way to accelerate that process, like some sort of subsidies or some encouragement from the government financially?
Well, the thing that is going on right now is that there's an inherent subsidy in any oil-burning device, any power plant.
200,000 years, at least in the ice. And they know that they've also done spectrometers into stone. They can scan it till it was there. Carbon dioxide was over 500 times stronger in the time of the T-Rex. Okay, in the Jurassic Age. That's why plants grew so fast, things were so big. There was a higher oxygen level. Just like Mars lost its atmosphere, used to have an ocean, they've now gone and proven. It lost its atmosphere. It's a smaller planet, couldn't hold it. Truth is, the Earth's losing its atmosphere. So what's crazy is we come right along at this time, pump up all of this juice and all this carbon that was produced on the surface with plants and animals that ran down in cracks into the Earth. We're now pumping out all that carbon saved from millions of years ago and actually terraforming the planet, putting more carbon dioxide in that we actually need right at this time. Like aliens figure this out or something.
But hold please. isn't carbon dioxide responsible for an increase in the temperature of the Earth?
But they said that we would have a 7 increase. They said that by 2013, all that LA would be flooded and New York would be flooded. All that's lies.
Okay, but let's forget about what they said in the past. What they're saying now is that carbon dioxide increase is responsible for an increase in the temperature of the Earth.
Which we hope it does. Because
we
we
hope it increases the
we're
temperature
set.
of the Earth?
The last ice age.
Hold on.
Joe,
The
the last
increase of
ice
the
age,
temperature,
listen.
but the increase in the temperature of the Earth is responsible for the increase in hurricanes, the frequency and the power of the hurricanes.
If you look up the spectrum in the last 100 years, hurricanes have gotten weaker. That's all media hype. But let me just tell you.
Oh, Jesus.
Joe, I swear to God, I can prove all this to you. This is so huge for your audience.
Are you a carbon dioxide salesman?
Listen, well, they always say I'm getting money from oil companies. I'm not. But can I please tell you what...
But anyway, I guess this summer has been febrile. The febrile summer of 2021 hammers home what we know and what we don't know about climate change. It can be summed up in 2 paragraphs, neither of which is comforting. Okay, paragraph 1. We understand about how much the temperature is going to rise if we keep pumping greenhouse gases into the atmosphere. I'm not getting into a debate with Bill McKibben about we know how much that we understand a little bit about how much the temperature is going to rise if we keep pumping greenhouse gases into the atmosphere or not from this point forward. This is Bill's sermon, not mine. Hi. This has been the central scientific preoccupation for more than 3 decades, translating gigatons of carbon and methane into degrees of warming, and researchers have got it more or less right. From James Hansen's original prediction in the late 1980s to the secret reports that Exxon scientists provided executives during the same period, the precision of these estimates increases the more we learn. New data this year on the effect of clouds, for instance, makes clear that they will do more to warm the Earth than to cool it, which was one of the last remaining uncertainties. Simply put, doubling the amount of greenhouse gas from before the Industrial Revolution in the atmosphere would increase the Earth's temperature somewhere around 3 degrees Celsius. That is what we are on track to do right now. It is a scary high number. I'm thinking, well, we're going to give the wind one more chance, and then I'm going to have to move the microphone to a windbreak if it's a problem. Okay. Point number 2. We understand much less about how much damage those 3 degrees would do. It's hard to build computer models powerful enough to calculate the rise in temperature, but infinitely harder to predict the resulting havoc, because that is a function of many things that we can't really measure. Some of the things are human. How will we respond as societies to catastrophe? It's perhaps not a great sign that many Americans worried about climate change are now heading to survivalist school. In the words of one attender, now I feel like, oh my God, I can set up a mud hut. Yes, I can set up a mud hut to survive the apocalypse. I am not going to go there. Anyway, moving along. But many of these unpredictables are physical. Consider the jet stream. It clearly governs much about life in our hemisphere, but until recently, few scientists suggested that it could fundamentally shift in behavior. And I think Paul Beckwith gives himself a lot of credit, probably deserved, that he was one of the few scientists raising the alarm about the jet stream going wacko. Now, the melting of the Arctic has reduced the temperature gradient between the equator and the North Pole, and that reduction in terms seems to be making the jet stream sluggish, setting up such events as the devastating European flooding. It would have been nice if he had attributed who this researcher, this climatologist was. There's a bunch of links in here. If you go on the link I'm going to provide, he links you to dozens of other, any one of which could come around. Quoting the unnamed climatologist from Potsdam Institute, we had a low pressure field over Central Europe which did not move. It was persistent and long lasting. Normally, our weather patterns moved from west to east, but this engine, the temperature gradient that we have, is weakened. Yes. There are plenty of other systems that we are now starting to really worry about. The marine equivalent, the Gulf Stream, the AMOC, is quite suddenly slowing, probably because fresh water is pouring off the Greenland ice sheet and disrupting the density difference that drives the great ocean currents. We don't know how close we are to poorly understood tipping points that can rapidly turn the Amazon from rainforest into savanna. Kelp forest, the rainforest of the sea that cover a quarter of the planet's coastlines, appear to have shrunk by a third in the past decade. In fact, name a large physical system on the planet, and chances are that it is now in chaotic flux. Yes, name a large system and look for your chaotic flux. The lesson to be drawn from all of this, the lessons to be drawn from all of this are not novel. One is that we need to slash greenhouse gas emissions with incredible speed in order to reduce the total amount of warming and hence reduce the pushing and shoving on basic physical systems. The other is that we need to prepare ourselves and our civilization for massive dislocations, but we really need to make ourselves think about what it means to be flying blind into the future. We focus a lot of attention on how much the temperature will rise because that is a knowable number. Our political, diplomatic, and economic debates are conducted as if it's the essential fact. But the scarier question is what each tenth of each degree will do. We don't know, and we can't really know. These fundamental systems are clearly intertwined, and their breakdowns are likely to cascade. When a team of researchers at the Massachusetts Institute of Technology published their landmark study, The Limits to Growth, in 1972, the eeriest part of the prediction was that societal collapse, set for some time in the next few decades, would come about from the somewhat opaque interactions of the world's systems. That is, the MIT team did not name a single cause that would inflict fatal damage on the planet. Their necessarily crude, at the time, computer modeling simply showed that past a certain point, chaos would ensue.
And a little more money on, exploring the heavens kind of thing. Exactly, and also on mitigating man-made disasters as well, because cataclysms don't only come from the cosmos; they can also be created by a species like ourselves. All of this is true.
Yeah. So yeah, I think I'm trying to figure out how to frame that, like why this stuff is important, because some people kind of brush off the historical perspective.
It's important, first of all, at a personal level. Every one of us likes to know our family background, where we came from. We often can't trace it back very far. I can't trace my own family back beyond my great-grandfather. I've heard vague rumors about what happened.
We begin in China, where large
but we like to
swathes of
situate
Henan
ourselves
province are underwater
in some
after
way.
being
It helps to give
pummeled
us a
by
sense of
torrential rain.
who we are and
Weather
where
forecasters
we
say
are.
it is the heaviest
And if this is
downpour
true
in
at an individual
1,000
level,
years.
it's also true at the
At
level
least
of the human
12
race. We
people were
want to know
killed
where
in
we
the
came
provincial
from, how we
capital
got
of
here, how we got into this
Zhangzhou, with
position.
floodwaters
And it's an
turning city
ideological
streets
position of the
into
mainstream
roaring
to
rivers.
depict
Authorities
the
have
human story of
evacuated
one of
more
more or
than
less constant
100,000
progress with a
people
few
to
little
safe
dips
zones
here and there.
as
More or
China's
less
military
constant progress,
blasted
as
a
John
nearby
Anthony West
dam
used
to
to put it,
release
from
floodwaters, threatening one of
the
the
Stone
country's
Age
most
to
heavily
us today with
populated
our striped
provinces.
toothpaste and whatever. But it's not. This is ideology. This is not a fact. This is how we wish things were. This is also part of the problem, is that we constantly look for ourselves in the past. And if we don't find ourselves, then we automatically define those cultures as primitive. Whereas there's many ways to be sophisticated. Ours is just one. And it's lacking in many important qualities that a civilization should have. But the worst thing of all is this arrogance, this sense that we've made it, we're safe, we're secure. There's nothing for our technology will solve everything for us. That is a huge error. Life on this planet is fragile. It can be diverted in its course very rapidly and very, very quickly. And I don't think that our civilization is resilient or strong at all. We do have some great tech, but we're so screwed up in so many ways that the tendency to specialize, for example, which is part of the success of our culture, also has a downside. It means that people are very good at doing one thing, but not very good at doing anything else. If you come to a global cataclysm, somebody who's a specialist in computer science isn't really going to be that much use in feeding his or her family. And it's why those who are most likely to survive a global cataclysm today, in my view, would be the meek of the earth. It would be those few remaining hunter-gatherer populations in the Amazon rainforest, in the Namibian desert. Those few remaining hunter-gatherer populations that still exist on the earth, these are people who know how to survive. They could pass through a horrendous global cataclysm and hardly be scratched. It wouldn't affect their morale, it wouldn't affect their outlook, their confidence, but it would destroy us, because our confidence is no longer based in our own abilities, it's based in what society as a whole provides us. And I think the psychic collapse of Western civilization confronted by a huge cataclysm would be extremely rapid and very, very awful. And we would be in a situation where people are just gunning each other down in the street very, very rapidly. We don't have the moral fiber to deal with a situation like that. We've got lazy, we've got idle, we've got far too secure, far too comfortable in our own wealth and privilege. And it's time that was questioned. And I think when we realize how fragile civilizations have been in the past, that even a great advanced civilization of the past may have been almost completely lost, leaving only a few traces, we have to realize that could be us too. We could be the next lost civilization.
Yes, almost on a long enough timescale, destined to happen. Right? I think ultimately.
Well, unless we grow up and change things, and it begins at the person to person level, and it spreads out to the nation to nation.
It actually threatens us with human extinction within a few decades. This is 1986 that he's making this statement, And he actually brings up the notion of human extinction within a few decades. And that was reported widely by the Associated Press. And finally, the United Nations Advisory Group on Greenhouse Gases points out in October of 1990 that if we cross the 1 degree Rubicon, if we warm the planet by 1 degree C, we're going to trigger all kinds of self-reinforcing feedback loops that start to feed upon themselves. I'm going to point out shortly that we've already triggered those at 0.85 C above average. And in fact, it appears that we triggered the first one, the most lethal of them, at about 0.76 degrees, 3/4 of a degree above average in terms of global average temperature. I'm going to take a look at some of the major assessments that have come out within the last 7 years or so, starting with the Intergovernmental Panel on Climate Change's much vaunted fourth assessment. It came out in late 2007, in which they predicted a more than 1.8 C temperature rise by 2100, depending upon the emission scenario, up to a 4.5 degree C temperature increase. Remember that according to the United Nations Advisory Group on Greenhouse Gases, beyond 1 degree C may elicit rapid, unpredictable, and nonlinear responses that would threaten extensive ecosystem damage. So 1 degree C is truly catastrophic, and we had the warning from the IPCC in their fourth assessment 7 years ago, the consequences of crossing that 1 C Rubicon. Hadley Center for Meteorological Research comes along about a year after the IPCC's fourth assessment and predicts about 2 degrees C by the end of this century. Shortly thereafter, the director of their climate change prediction group for the Hadley Center says it's more likely that we'll experience between 5 and 7 C temperature rise. It's difficult for me to imagine a scenario in which there are any humans on the planet at 5 C above baseline. Again, we've never experienced a planet at 3.5 C above baseline that had habitat for humans. United Nations Environment Program comes along in mid-2009 and predicts 3.5 C by the end of the century. Notice all of the projections are for at the end of the century, or some 80 plus years beyond where we are right now. Hadley Center for Meteorological Research comes along just about a year after the previous assessment and says 4 is the new 2, and it's coming by mid-century. Global Carbon Project and Copenhagen diagnosis at the time of the COP15 meetings, Conference of Parties meetings in Copenhagen that were thrown under the bus primarily by the United States presidential administration. And they conclude 6 or 7 C respectively by century's end. United Nations Environment Program comes along again and predicts not 4 C by mid-century, but up to 5 C by 2050, by mid-century. And finally, the U.S. Department of Defense in their quadrennial defense assessment, comes out every 4 years. So in their quadrennial assessment put out in 2010, lists climate change among the most dire threats to not our species, not to industrial civilization, but to national defense, which of course is their primary concern. And finally, the Intergovernmental Panel on Climate Change in their fifth assessment, the first portion of which was released a little bit early, all of which has been heavily leaked at this point. And in their fifth assessment, the IPCC points out that global warming is irreversible without massive geoengineering of the planet's atmosphere. What does that mean? What does that look like? Let's take a look at some of the notions behind geoengineering. Again, the IPCC, in the report already leaked and due out this year, and in fact, a second part of the report is going to be released on Monday, 2 days from today. And they point out that we've hit irreversible climate change in the absence of geoengineering. Then, in a classic case of closing the barn door after the horse has already escaped, we have a series of journal articles that take on the task of analyzing the consequences of geoengineering. The first of those was reported in Earth System Dynamics in December of last year, in which, quote, climate geoengineering cannot simply be used to undo global warming. There's no going back. the horse is already out of the barn and chasing down the horse and shuttling it back into the barn, it's too late to do that. Journal of Geophysical Research points out the same month geoengineering may succeed in cooling the Earth, but it likely will have catastrophic impacts that are unforeseen. Environmental Research Letters, January, so just about 2.5 months ago, attempts to reverse the impacts of global warming by injecting reflective particles into the stratosphere could make matters worse. And that's the most commonly proposed approach to geoengineering, is to put particles into the atmosphere, sometimes called solar radiation management, or SRM. Environmental Research Letters, another paper coming out just over a month ago, reports that risk of abrupt and dangerous warming is inherent to the large-scale implementation of solar radiation management, of SRM. And so we can put those particles up there into the atmosphere, but they point out that it has to be a continuous process. We have to continually put particles into the atmosphere. The moment we stop, particles fall out, and they predict catastrophic and immediate rise in temperature as soon as SRM, or solar radiation management, ceases. Finally, in Nature Communications from just about a month ago, the risk of current schemes, and they do an overview of a variety of approaches to geoengineering in that paper. And what they conclude is that current schemes are likely to either be relatively useless or actually make things worse. So implementation of the various geoengineering strategies that have been attempted is likely to have little effect or actually make matters worse. And finally, also from the refereed journal literature from Nature Climate Change, the public isn't interested. There appears to be very little positive response to the notion of geoengineering from the public. So not only does it look like it won't work, but the public is on board with it not working and thinks it's a terrible idea. John Davies, writing for the Arctic Methane Emergency Group in September of last year, this is a great quote, concludes that the world is probably at the start of a runaway greenhouse event which will end most human life on Earth before 2040. Davies is only taking into account carbon dioxide into the atmosphere. He's not accounting for the handful of other greenhouse gases, including methane, that are being emitted as a result of industrial civilization. Take a look at the figure here, and you can see that according to NOAA and NASA, the carbon dioxide levels, which did not exceed 300 parts per million for at least 650,000 years, are now at about 400 parts per million. We never had humans on a planet above 320 parts per million in the past. So right there at the knife edge with 400 parts per million of carbon dioxide into the atmosphere. So far, we're only considering carbon dioxide in the atmosphere. The good news about these large-scale assessments is that they do not include collapse. They don't include cessation of this set of living arrangements. And when I talk about collapse, what I'm thinking there is no fuel at the filling stations, no lights in the studio or elsewhere, no water coming out of the municipal taps, no food at the grocery store. So when industrial civilization reaches its overdue end, and we don't have carbon being emitted into the atmosphere as a result of burning fossil fuels, that's collapse. The good news is none of these assessments take into account collapse. The bad news is twofold. First, when collapse comes, it triggers Fukushima meltdown